Hello everyone and welcome to section 6.4, which is on rectangles. So first, starting off, we've got a definition of a rectangle, which is a parallelogram, which we've already done parallelograms, but this one has 4 right angles. So a couple theorems to start us off is theorem 6.13 that says if a parallelogram is a rectangle, then its diagonals are congruent. Theorem 6.14 is like the same thing but in reverse, and it says if the diagonals of a parallelogram are congruent, then it is a rectangle. Okay, next, we're going to list the 8 properties of a rectangle. So our first property is that the opposite sides are parallel. Number 2. 2 says that the opposite sides are congruent. 3 says the opposite angles are congruent. 4 says that the consecutive angles are supplementary. 5 says the diagonals bisect each other. They cut each other in half. Number 6 says the diagonals separate into 2 congruent triangles. So those are all properties of a parallelogram. The 2 new properties that we're going to add on are specific to rectangles, which is number 7, and that is that they have 4 right angles. And then number 8 says that the diagonals are congruent. So these 2 are specific to triangles. Okay, moving on. Number 1, practice problems. We are looking at FD and EG. FD is this diagonal. EG is this diagonal. And we are told that FD is 3x minus 7 and EG is x plus 5. We need to find EG. So in a rectangle, it tells us that it is a rectangle. It says it right here. That we know that the diagonals are congruent to each other. So congruent means equal, so I'm going to set these equal to each other. Equal. Subtract x from both sides, sure. 2x minus 7 equals 5, add 7. 2x equals 6, divide by 2, x equals, or not 12, that's 12, x is 6, there we go. X is equal to 6. Now we need to go back and answer the question. We need to find EG. EG, remember, is 5x plus 5, or not 5x plus 5, just x plus 5. So instead of x plus 5, I'm going to do 6 plus 5 because x is 6. So 6 plus 5 is 11. So EG is 11. Next, number 2, I'm going to erase some of this stuff. Number 2, we are given angle EFD. EFD is EFD, this angle. We're told that that is 2x minus 3. We're also told that angle DFG is x plus 12. We need to find the measure of EFD. So those 2 angles make up one whole angle in a rectangle. And remember, all rectangles have all 4 right angles, which means that corner is a right angle. So those 2 angles add up to 90. They make a right angle. So 2x minus 3 plus x plus 12 has to equal 90 because this is a rectangle. I'm going to combine my like terms. So I've got 2x and 1x. That's 3 total x's. And then I've got minus x and a 12. That is a plus 9. So I've got 3x plus 9 equals 90. I'm going to subtract 9 from both sides, and I get 3x equals, 81. Divide by 3. Divide by 3. I don't know what the heck that is. I think it might be 27. I think. Let me see. Yeah. So x is 27. Next, we need to find EFD. EFD, remember, is 2x minus 3. So instead of 2x minus 3, I'm going to do 2 times 27 minus 3 because I just found out x is 27. So 2 times 27 is 54 minus 3 is 51. So that angle is 51 degrees. Moving on to number 3. So in this one, we have to graph the quadrilateral and determine if it is a rectangle. And it tells us that we have to use this method that they tell us to use, which is the slope formula. Remember, the slope formula is y2 minus y1 over x2 minus x1. That is the slope formula. But first, I'm going to graph my points because that just seems like a good place to start. So, graph my points. W is at -4, 3, which is right here. That's W. X is at 1, 5, which is 1, 2, 3, 4, 5, right here. X. Y is at 3, 1. Y. And Z is at -2, -2. There's Z. So it kind of looks like a rectangle, but what I really need to be checking for is I need to be making sure that the slopes in the corners, so like say between these two, I need to make sure that those are perpendicular slopes, because remember, perpendicular lines make right angles. If those are perpendicular, then I know that that is a right angle, so that's a good place to start and look for a rectangle. So let's pick 2 points to start with. I'm going to choose W and X, and I'm going to find the slope between those two using my slope formula. So I'm going to call this one X1 and Y1, and this one X2 and Y2. Plug those right into my formula. Y2 is 5 minus Y1, which is 3, over X2, which is 1, minus X1, which is -4. So 5 minus 3 is 2, over 1 minus -4, which is 5. So that's the slope between WX. And remember, I'm looking for perpendicular slopes, which is means I'm looking for the opposite reciprocal. Perpendicular slope. So far I've gotten 2 over 5. The opposite reciprocal of 2 over 5, well, remember, opposite means sign. So if this is positive 2 over 5, so my new slope should be negative, and it should be the reciprocal. So flip the top and the bottom of the fraction. So 5 on top, 2 on the bottom. That is what I should get. So let's check and see if I do get that. I'm going to check between X and Y and find the slope between those two. So we'll call this one X1 and Y1 now, and we'll call this one X2 and Y2. Okay. X2 or Y2 is 1 minus Y1 is 5 over X2, which is 3, minus X1, which is 1. 1 minus 5 is -4 over 3 minus 1, which is 2. So simplify this, -4 over 2, that simplifies just to -2. Do these match? No. Therefore, this is not a perpendicular slope, so this is not a rectangle. It did not have perpendicular slopes in the corners. Okay, last problem, number 4, is a proof. So first things first, I'm going to write down my givens. My first given is that ABDE is a rectangle. And then there was a second one that said that BC is congruent to DC. Those are givens. Well, okay, so it's kind of already marked that for us, so I'm not going to make any other changes. But let's look at what we need to prove. I need to prove that AC is congruent to EC. It's going to be kind of hard to do, but the way I'm going to go is I'm going to prove that those triangles are congruent first. So first thing first, I'm going to say that this side is congruent to this side. AB is congruent to ED. And that is because opposite sides are congruent. It's a rectangle. Okay, so you might be looking at this triangle so far and you're like, that's pretty good. Yeah, we've got two sides that we already know of those triangles that are congruent. The next thing I'm going to say is that these are right angles. Angle B is a right angle, and angle D is a right angle. And that is a property of rectangles. So I'm just going to put rectangles have or right angles. Next, since those are both right angles, that means that they're both 90 degrees. Right angles are congruent to each other. So I'm going to say angle B is congruent to angle D. And that is from a theorem that we learned way back when, but that says all right angles are congruent. Which is true. They're all 90. So now I know that I have two sides in an angle, so I'm going to say that those triangles are congruent to each other. So, triangle ABC is congruent to triangle EDC. That is by side angle side congruency. Side angle side congruency. And now that I know that those triangles are congruent, I can say that their corresponding parts are all the same too, which means this third side is congruent to each other. And that will finalize our proof. AC is congruent to EC. And that is by CPCTC. That I know that. Corresponding parts of congruent triangles are congruent. And that is my full complete proof. And that completes day, what is it, 6.4? So I'll see you guys in 6.5. Bye.